Yes, sir, you are properly audible now. You can continue with your PPT, sir.
हेलो गार्गी बेटे, इसमें दिक्कत आ रही है, मुझे लग रहा कुछ इसका जो है ये सेटिंग वेटिंग गड़बड़ हो गया, इसमें टाइम लगेगा। ये मुझे वो करना, प्रेजेंटेशन दे देता हूँ और उसी से आप रिकॉर्ड करके मैं आपको भेज दूंगा, या आप रिकॉर्ड वहीं से हो जाए। हेलो, अच्छा ठीक है, ओके ठीक है। So hello, very good morning all of you. Sorry for the disturbance because of some setting problem. Actually this MS Team it is not in much use. We generally use the Google Meet or okay. So now you can hear me, please. Who is coordinating the session?
Yes,
Yes,
sir,
sir,
you
now
are
yes.
properly audible.
Hello.
Sir, you are properly audible, sir. You can continue with your PPT. Thank you, sir.
हेलो, आप बोलेंगे मैम, आवाज आ रही है राखी मैम?
Yes, yes, sir, you are
Yes,
audible.
sir, you're audible.
उनको
हेलो। आपकी आवाज नहीं, अब आपकी मुझे नहीं आ रही है, बहुत कमाल है। हाँ, अच्छा, तो मुझे रेस्पॉन्स नहीं मिलेगा, कैसे काम होगा फिर? तो ऐसा हो सकता है क्या कि उधर से कोई मोबाइल वोबाइल कनेक्ट करके रख दो जो मुझे अजीब हाल है। हाला, अच्छा मैं शुरू करूं? हाँ मैं, अच्छा अब अच्छा ठीक है, मैं शुरू करता हूँ। ओके, ये फोन कनेक्टेड रहने तो मैं बोलता रहूंगा, इधर कोई अगर आपका कॉल है तो उठा लेना, नहीं तो कोई क्वेश्चन वोश्चन होगा इसी पे कर देंगे कोई। हाँ हाँ, ओके, इसे प्लीज कीप ऑन कनेक्टेड दिस।
ठीक है सर, कनेक्टेड रहने।
हाँ, सो thank you Gargi. Thank you so much. I am sorry for this all disturbance because of this. You see, we are in the technology age, but sometimes technology also create lots of problem. So first of all, I congratulate to the entire team for organizing this AICT sponsored ATAL FDP on cross modality innovation, generative AI in language, image intelligence, and medical advancements, organized by the Department of Computer Science and Engineering, Bharati Vidyapeeth, College of Engineering, New Delhi. Now today I will be discussing about AI in image processing, enhancing vision across modalities. So first let us just briefly discuss about how the image processing came into existence, or how the evolution of image processing came across various methods, starting from the Laplace transform, then Fourier transform, then fast Fourier transform, then discrete Fourier transform, sine and cosine transform. Then it came wavelet transform, multi-resolution analysis, wavelet packets, CLA transform, and then finally we came to the AI and machine learning applications to image processing, the advanced latest version. So the first analysis of the signal and image processing started through Fourier transform in 1768 to 1830 by Joseph Fourier. I will not go to the any details of the Fourier transform or all the transform. Just I will in 5 minutes I would like to overview before coming to the main topic. Basically, the Fourier series difficulties were having some different periods is not efficient. Fourier series does not converge. You can see from the figure that at converging points, the Fourier series has some difficulties. Then it came to the Fourier transform. You can see from the figure how the Fourier transform is happening. These are the one of the examples of Fourier transform of a signal. So the basic problems of the Fourier transform in the starting were drift, trends, abrupt changes, beginning and ends of events. Then a solution of this Fourier transform, these problems were shortly solved by the short Fourier transform, in which we were having the windowing of the signal, that is breaking the signal into short windows and then analyzing the amplitude and the frequency of the signal, as you can see in the figure. The fast Fourier transform was a compromise between time-based and frequency-based. Then it was having the limited precision and also the size of the window. These are some examples of the short Fourier transform. Please ask if any questions in between. I will be happy to reply, because then you can see one of the example of the short Fourier transform, where we have the short windows and you can see the different resolutions of 25 milliseconds, 125 milliseconds, 375 milliseconds and 1000 milliseconds. These are some 3D pictures of the short Fourier transforms. Then next stage was the transform based technique of image processing, in which we were having the basic structure of the transform based technique was transformation, quantization and entropy encoding. You can see from the figure that the pre-processing of a medical image, then forward transform. In basically forward transform, we started with the DCT, that the discrete cosine transform, and then later we were having the wavelet transform. So these are the forward transform, quantizer, symbol encoder, and the same way. So the initially the DCT was very much useful. Even today in the JPG images, some of the images we use the DCT, but the problem with the DCT is the 8 by 8 pixels blocking is there, and we have the blocking artifacts in DCT transforms. This is the basic equation of the DCT transform. Here, discrete cosine transform has the 8 by 8 blocks, and while we recombine these blocks, so we have the problem of the this blocking artifact. So the DCT also could not be very much popular. You can see here from here that how the blocking effects in the DCT transform is reflected very clearly. You can see here also. Then we next stage we came to the wavelet analysis. In the wavelet analysis, you can see as the main problems of the Fourier transform, fast Fourier transform, discrete Fourier transform, that we were having the problem of the resolution and frequency and time together we were not able to show. So the wavelet transform with the properties of short time localized waves, possibility of time shifting, different scales and shapes, and the flexibility. So the wavelet transform become very popular. Even today, wavelet transform is very much popular. You can see by this window. that how the a signal of amplitude and time through wavelet transform can be converted into wavelet transform through having variable scale and time both in the outcome. So the beauty of the wavelet transform, you can see here that while in other transforms we could not have at the same time both resolution, frequency, time, all these three parameters. So here you can see the three parameters together in one go. If you want better time resolution, then you can opt the upper half. And when you opt if you want the better frequency resolution, you can opt the lower band region. So this way you can have both the things, resolution as well as frequency option in the wavelet transform. These are the various domains of the various transforms. Here you can see very clearly that when we apply the this is a signal, 1D signal, sorry, 2D signal. Here we have one breaking of the signal at one point. So when we analyze this through Fourier transform, we are not able to find it out, whereas when we are analyzing this through the wavelet transform, we can analyze this, we can find out this point so we can very easily, you can see, find out here this the problem. So this is the wavelet analysis, how the sine wave and wavelet are different. This is a dB10 figure here. These are various wavelets. You can see this is the mother wavelet, the basic formula of the mother wavelet. The wavelet is variable in two parameters. A is the scaling and B is the shifting. So if you want to shifting it, then we can vary the B, and if you want to scale it out, that we want to, then we have shifting of A. So these are the various, these are the properties of the wavelets. I will not go in much detail of that. So this is important. We have different types of the wavelets. There is in the MATLAB, we have complete wavelet toolbox from, we can refer that also. Then we have the wavelet families. These are the wavelet families. Wavelets in multiple dimensions. We can see this. Wavelets in multiple dimensions. Then we have some wavelet applications. You can see suppressing signals. And then we have denoising. So this is just a brief overview how the up to today, yani from starting from the wavelet, from the Fourier transform, fast Fourier transform, then having the cosine transform, then we have the wavelet. In wavelet we have various theories. One of the very important theory is the multi-resolution analysis theory, in which we can see some of the, in multi-resolution theory, we can have some of the yes, so multi-resolution theory of the wavelet transform is very much useful and yeah, very much applicable because of the its facility of having the multi-resolution property. A detailed work of this on wavelet transform, we have done it. We have a lot of work on this. Now, next stage we come to the that is of the today's topic, that is how the AI and machine learning came into picture. And how this is giving the analysis of or helping in the image processing. So first, let us just understand what is image processing, what is the purpose of the image processing. Basically, the image processing is a method to convert an image into digital form and perform some operations on it. That may be filtering, that may be compression, that may be feature extraction, and that may be video coding. Any action you can perform on the image through the image processing to get the features of the image, or to change the property of the image. This you can do through the image processing. It gives an enhanced image to extract some useful information from it. It is a type of signal dispensation in which input is image like video, frame, or photograph, and output may be image or characteristics associated with that. It treats images as a two-dimensional signal while applying already set signal processing methods to them. It is among rapidly growing technology today with its application in various aspects. Image processing forms core research area within engineering and computer science. Now, the another application of the image processing next stage is medical imaging or the biomedical imaging, on which your FDP is that basically the title focused on the of your FDP, that is the medical imaging or medical image modalities. So in medical image particularly, we analyze the medical images through different techniques, maybe wavelet transform, or through machine learning, or through AI techniques, or through some soft computing techniques may be used for ANN, fuzzy, or genetic algorithms that we can use. So medical imaging, it is concerned with interaction of all forms of radiation with tissues. The technique and process of creating visual representations of the interior of a body seeks to reveal internal structures hidden by the skin and bones, as well as to diagnose and treat disease. Also establishes a database of normal anatomy and physiology. It is a technology to extract clinically useful information, usually in the form of an image for medical diagnosis. So these are some of the actions which we do on the medical images. These are some of the basic applications in medical imaging, that is intelligent transportation system of image processing applications, remote sensing, moving object tracking, defense surveillance, automatic visual inspection, and biomedical imaging, feature extraction. These are some applications of the image processing. So now we will be discussing some of the basic image modalities which we generally handle in the medical imaging or in the medical image processing. So first, the very first comes to the X-ray, that is through radiography. So X-ray does not give the detailed information about the organ. It may cause skin cancer if it is used multiple times. This technique is less expensive and easy to use. Everyone knows about the X-rays. Then the extended version of X-ray is the computed tomography, or we can say the CT scan or CAT scan. It makes use of computer processed combinations of many X-ray measurements taken from different angles. It helps in providing more clear information than X-rays, and its risk of radiation exposure is very low. Then next, the medical image modality is MRI. That is magnetic resonance imaging. It has superb ability to discriminate between subtle differences in tissue characteristics. MRI does not involve X-rays or the use of ionizing radiation, which distinguishes it from CT or CAT scans at PET. Then next, then we have the ultrasound imaging for the soft tissues. Its advantage is that it provides image in real time. It is portable and can be brought to the bedside. It is substantially lower in cost, and it does not use harmful ionization radiation. Then the next medical image modality is the position emission tomography. In this, a radioactive material is injected In this, a radioactive material is injected in the blood and a scanner detects this material to get the image. This technique gives an idea of brain's activity and function. This method is less cost effective and harmful. Then we have the fundus image. It is performed by a fundus camera, which basically consists of a specialized low power microscope with an attached camera and a posterior pole. You can see this very interesting image. You can see. Now we come to the basic medical image processing system. In the basic medical image processing system, we have acquisition, then processing, then we have visualizing or reporting. So through processing, we mean that we have the pre-processing, then we may have the segmentation, then we may have the detection, then we may have analyzing, and then we may have feature extraction and diagnosis. So this is the basic image processing system. Though many steps are hidden over here, they will be discussed in the next PPTs. So this is the basic structure of the medical image processing system. Now the first one comes the feature extraction. Why we do the feature extraction from the medical images? It is a dimensionality reduction process where an initial set of raw variables is reduced to more manageable groups for processing. The first point. Second is the features of interest are detected and represented for further processing. Critical step in transition from pictorial to non-pictorial data representation. The resulting representation can be used as an input to the number of pattern recognition and classification techniques. Goal of feature extraction is to improve the feature and attribute of an image. Features should be involved to rotation, scaling, and translation. And with the help of the feature extraction, then only we can go to the diagnosis process. First, once the features are extracted, and if the features are of helpful to diagnose a particular disease from a medical image or medical image modality, then only we can say the image processing tool is useful or it is helping. These are classification of the features. This is one of the most important part of the medical image processing, that what feature you require and what is the purpose of that particular feature. So if we talk on the based on the shape, if we talk on based on the shape, then we will require for the features that is the circulatory area, that is the irregularity, shape, perimeter. So these features will be based on the shape of the image modality. Next is the based on intensity. If we talk of the intensity of the feature, then we have mean, standard deviation, variance, median, skewness, pixel orientation, and that is kurtosis range. These are some of the features based on the intensity of the image. If we suppose we find a standard deviation, we can predict something about the intensity. If we find the mean of the image, or we find the variance or the median or the pixel orientation, all that will represent the intensity of the image. Then if we want the texture, the third important feature of the image is the texture. Suppose we want the texture, then we need what? We need contrast, number one. Then we need cluster shade, number two. Then sum of squares, inverse difference moment, correlation, energy sum average, mean entropy, sum variance, difference variance. Then we have difference entropy, inertia, cluster prominence. So these are some of the features which are based on the texture. If you want to predict about the texture of the images, you need these images. If you need to predict the shape of the images, then you need the first one. If you need the intensity to declare something about the intensity, you need these things. So these are three basic features of an image. Now, properties of a good feature. Any question, please? If anyone have any question regarding this, we will be happy to reply. गार्गी जी कोई रेस्पॉन्स नहीं आ रहा उधर से, मतलब वन वे कम्युनिकेशन है. हेलो हेलो हेलो.
हेलो सर.
हाँ, मैं कह रहा हूँ कि आपको आवाज आ रही है, मैं अकेले को
हमें आ रही है, इसलिए नहीं आ रही है क्योंकि मैं अभी आप जब क्वेश्चन पूछेंगे ना तो फिर मैं आपको अनम्यूट करके स्पीकर फोन का सुना दूंगी ना फिर जब क्वेश्चन.
अच्छा अच्छा, हाँ, तो इसलिए मैं विजिबिलिटी ठीक है ना? इज इट तो
फिट चल रहा है सर.
अच्छा, ओके, थैंक यू, लेट मी. हाँ, ओके
जी सर.
So next we go about the properties of a good feature. So first I have discussed the classification of the features. This is those who are working on research on this feature medical imaging or image processing, who are new people want to do PhD. So Dr. Gargi has also done PhD in this area, I think. And IIT Roorkee, IIT Delhi, they are very good labs. In GBU also, we have very good facilities regarding these biomedical lab, medical imaging, feature extraction, all that research is going on. So now, what are the properties of a good feature? First, it is the repeatability. Means should be detectable at the same location in different images despite changes in viewpoint and illumination. First property of a good feature. Then second, we must have saliency or descriptiveness. So that is same points in different images should have similar features and vice versa. And the third one is the compactness. So these are three main properties of a good feature while we are extracting the feature from an image. Then now comes the role of the AI. That how the, as I told you that in the that from the beginning that image processing started from the Fourier series, even you can say from the Fourier series. Then we had the Fourier transform. Then we have the fast Fourier transform. Then we have the sine and cosine transform. Then we have the wavelet transform. And in wavelet transform, we have the two theories, that is the multi-resolution theory and the continuous wavelet transform. And then now next stage, we are coming to the some computational where tools are involved through the AI and machine learning and the soft computing. So that part now plays a very interesting role in the image processing, which we are discussing here. So first, let us have briefly that what are the various parameters of AI and the machine learning which may be useful in the image analysis. So artificial intelligence, everyone now talks about the artificial intelligence. And if you are able to anyhow incorporate some intelligence in the system or the machine, then we can say it has some application of AI. So AI is a machine's ability to perform cognitive functions as humans do, such as perceiving, learning, reasoning, and solving problems. The benchmark for AI is the human level concerning in terms of reasoning, speech, and vision. So AI may be summarized in 3 points applicable to the image processing: an intelligent entity created by humans, capable of performing tasks intelligently without being explicitly instructed, capable of thinking and acting rationally and humanly. So these are some, you can say that, expected things from the AI. However, the 100% as of now, we cannot say that everything is uh, working the same way as humans do. But the effort is going on, and AI is booming nowadays. Goals of AI are to help us reduce the amount of time needed to perform a specific task, making it easier for humans to interact with machines, facilitating human computer interaction in a way that is more natural and efficient, improving the accuracy and speed of medical diagnosis, helping problem learn new information more quickly, enhancing communication between humans and machines. So these are the various types of the AI. You can see that AI now basically artificial narrow intelligence, that is called ANI, first category. You can see in the figure, artificial narrow intelligence category, in which machine learning specializes in one area and solve one problem. So these are some examples given downside. The next stage is the artificial general intelligence, AGI, second figure. That is the stage 2, in which we incorporated machine intelligence. Refers to a computer that is as smart as a human across the board. And then third stage is the artificial super intelligence, ASI, stage 3, machine consciousness and intellect that is much smarter than the best human brains in practically every field. So these are the various three stages, you can say, of the AI. So all these three, we have the first one, that is the artificial narrow intelligence. The artificial intelligence systems are designed to solve one single problem and would be able to execute a single task really well. By definition, they have narrow capabilities, like recommending a product for an e-commerce user or predicting the weather. Second is AGI, that is artificial general intelligence. It is defined as a AI which has a human level of cognitive function across a wide variety of domains, such as language processing, image processing, computational functioning, and reasoning, and so on. Then third one, we have artificial super intelligence. In this, the ASI system would be able to surpass all human capabilities. This would include decision making, taking rational decisions, and even includes things like making better art and building emotional relationships. So these are some subfields of the AI. You can see in the figure very well that the deep learning, machine learning, and AI. So deep learning and machine learning are the subset of AI. Is a you can say superset. In order to understand how AI works, one needs to help dive into the major subdomains AI and understand how the domains could be applied to the various fields. So first, AI, ability of machine learning to imitate intelligent human behavior. Application of AI that allows a system to automatically learn, improve from experience. Application of machine learning that uses complex algorithms and deep neural network to train a model. So the various applications of deep learning, machine learning, and AI, you can understand here in three different domains. इस पे किसी का कोई क्वेश्चन है तो आप पूछ सकते हैं. Then we will discuss one by one deep learning, machine learning, and AI. Then we will come to the application part and or the case study. So the machine learning. Machine learning is the most popular technique of predicting the future or classifying information to help people in making necessary decisions. First point. Machine learning algorithms are trained over instances or examples through which they learn from past experience and also analyze the historical data. With the help of machine learning, we can develop intelligent systems and are capable of the decisions and autonomous basis. The machine learning based algorithms learn from the past instances of data through statistical analysis and pattern matching, and based on the learned data, it provides us with the predicted results. So this because we based on the statistical data or the pattern matching, the machine learning algorithms give, so it may be very useful for the medical imaging, because we need the predictions, future predictions through previous data. Suppose we want to forecast some previous disease, or we want to forecast some database analysis. So the machine learning applications are very much useful in the medical imaging or medical image analysis. Then the next question comes, why machine learning matters, or how machine learning matters. With the rise in the big data, as we know that medical data is big data, machine learning has become a key technique for solving problems in areas such as computational finance, we can have through machine learning, image processing and computer vision that we are discussing through machine learning, like face recognition, motion detection, and object detection or feature extraction. Then we have the computational biology. The biotechnology area also uses a lot of machine learning algorithms for tumor detection, drug discovery, and DNA sequencing. Then we have energy production for price and load forecasting. Then automotive, aerospace, and manufacturing for predictive maintenance. Natural language processing for voice recognition applications. This is the one of the basic figure how the machine learning works. The machine learning process starts with inputting training data into the selected algorithm, training data being known or unknown data to develop the final machine learning algorithm. So we take the input data, analyze, then we find the patterns, then we predict, and then strokes or feedback. So these are some steps in detail we will discuss. So this machine learning basically works on two algorithms mainly, supervised learning and the unsupervised learning. So the main learning used in machine learning is first supervised, which trains a model on unknown input and output data so that it can predict future outputs. So you can see the supervised learning algorithms are very much helpful in the medical image analysis. The second one is unsupervised learning, which fields hidden patterns, so intrinsic structures in input data. So while we are using this supervised learning, group and interrupt data based only or input data, and through this we get the clustering. We can make the clustering of the image data. Now if you want the classification and regression, then we need the supervised learning. In the supervised learning, develop predictive model based on both input and output data. So first unsupervised, and then second supervised. In the supervised, we can see that we can have the classification as well as the regression. So for the analysis purpose, we need both type of the algorithms, that is the supervised and unsupervised. Then only the purpose will be solved. So the unsupervised learning draws inferences from data sets that don't have labeled responses associated with the input data. Second is the clustering is the most common unsupervised learning technique. It puts data into different groups based on shared characteristics in the data. Then on the other hand, supervised learning requires each example of the input data to come with a correctly labeled output. Classification techniques predict discrete responses, and regression techniques predict continuous responses. You can see the difference, that classification, regression, or the clustering, three things, how they are correlated in the image processing. Again, the big difference here between supervised learning and the unsupervised learning is that supervised learning requires correctly labeled examples to train the machine learning model, and then use the model to label new data. Whereas, keep in mind the techniques you use and the algorithm you select depend on the size and the type of data you are working with, the insights you want to get from the data, and how those insights will be used. Then this is how do you decide which machine learning algorithm to use. So here you can see that machine learning, choosing the right algorithm can seem overwhelming. There are dozens of the supervised and unsupervised machine learning algorithms, and each takes a different approach to learn. There is no best method or one size fits for all. Many times there are questions that which is the best algorithm, which is this, which is this. You see, for different purpose, you need the different algorithms. So here a category of the algorithms is given. So there is no best method or one size fits all. Finding the right algorithm is partly just trial or and error. Even highly experienced data scientists can't tell whether an algorithm will work without trying it or not. But algorithm selection also depends on the size and the type of data we are working with, the insights you want to get from the data, and how those insights will be used. So machine learning, the two algorithms, you can say that the supervised in two categories. I told you the classification and the regression. So in the classification part, if we know want to have the classification part, then we can have the support vector machine. We have discriminant analysis, naive Bayes, and nearest neighbor. So these are few algorithms for the classification. Then if we want the regression, we have linear regression or Gaussian regression or support vector or ensemble methods, decision trees, neural networks. So these are for the regression. And for clustering, we have k-means, then we have c-means, fuzzy, hierarchical, Gaussian mixture, neural networks, and hidden Markov model. Some other methods are also there. So on the basis of the requirement, you can see we decide that we decide that which algorithm to be used. So supervised learning is chosen only if you need to train a model to make a prediction. For example, the future value of a continuous variable such as temperature or stock price or a classification. For example, identify makes of cost, welcome, video, footage, all that. Unsupervised, if you need to explore your data and want to train a model to find a good internal representation such as splitting data up into clusters. So then we need, so for different purpose we need different. So these are the now various types of the machine learning. As I told you in the figure, the three types of algorithms: supervised, unsupervised, and reinforced learning algorithms. So particularly that is the supervised learning. You can see that in the classification we can have image classification, we have customer then diagnostics, identify fraud detection. These comes in the classification. Then if we want to talk about the regression, then we have weather forecasting, market forecasting, estimating life expectancy, then with population growth prediction. All these things we can have the through regression. So in the supervised, two categories, classification and regression. Then we talk unsupervised. Unsupervised, we have also two categories. One is the clustering and other is the discriminantly reduction. So in the clustering, we have recommender systems, targeted marketing, customer segmentation, meaningful comparison, and then big data visualization. structure discovery, and feature selection. So then we have reinforced learning. In the reinforced learning, if you want to the gaming through AI, skill acquisition, learning tasks, robot navigation, real-time decisions. So these are the reinforced. So three categories of the machine learning algorithms can be defined very broadly. Approximately 70% of the machine learning is supervised learning, while unsupervised learning accounts for anywhere from 10 to 20%. The remainder is taken up by reinforcement learning. So you can see that 70% of this is covering the supervised, 10 to 20% unsupervised, and remaining 10% the reinforcement. So supervised, you can say the example of the supervised, how the supervised. In the supervised learning, the basic idea always we have the trainer there available. So some known data is there. Then we apply some machine learning algorithm. Then we have the processing. Then we have trained model, and we have the unknown data, and we knew response. So this is the basic model of the supervised learning. Similarly, we have in the unsupervised learning, we have what we have. We have the unknown data. We apply machine learning algorithm. Then we process it. We have trained model, and you can see the response. So this is the basic difference between the supervised and unsupervised. Then the in the reinforcement learning, as I told you that, like traditional types of data analysis, here the algorithm discovers data through a process of trial and error, and then decides what action results in higher rewards. Three major components make up reinforcement learning, that is the agent, the environment, and the actions. So these are the some main parts of the machine learning in detail. Agents, environments, and the actions. The agent is a learner or decision maker. The environment includes everything that the agent interacts with, and the actions are what the agent does. Then in the reinforcement learning occurs when the agent chooses actions that maximize the expected reward over a given time. This is easiest to achieve when the agent is working within the sound policy or framework. Now, before going to the application part or the application of these algorithms, we can see that why the machine learning is important. You can see in the figure, the better understand the use of machine learning, consider some instance where machine learning is applied: self-driving Google car, cyber fraud detection, and online recommendation engines from Facebook, Netflix, or Amazon. Machines can enable all of these things by filtering useful pieces of information and piecing them together based on patterns to get accurate results. The process flow depicted here, you can see in the figure how the machine learning works. So here are two phases. In the phase one, we have the training data. Here you can see we have the training data, and then here you can see the training data. And then we have the pre-processing. In the processing part, what can we do? We do normalization, dimension reduction, and image processing, etc. So this is the pre-processing. If there is an image, we need the pre-processing to filter it out any noise if there. Then second stage is the learning. What learning? Supervised, unsupervised, or minimized, etc. So which learning you need? Then error analysis, precision, recall, overfiltering, test, cross validation, data, etc. So these are the three stages in the first phase. In the second phase is the prediction part. So in the prediction part, we take the from the new data and a model, trained model, then mix it up and predict and then we get the predicted data through comparison. This is an important part, that from the new data, that is first one is the model, prepared model, and then we compare or we predict through this in the phase 2, that is called the prediction. So that is why the machine learning is important. So the rapid evolution of machine learning has caused a subsequent rise in the use cases, demands, and the sheer importance of machine in modern life. Machine learning has also changed the way data extraction and interpretation and done by automating generic methods, algorithms, thereby replacing traditional statistical techniques. Some most common machine learning approaches: regression, decision tree learning, support vector machine, association rule learning, ANN, inductive learning, reinforcement learning, clustering, similarity, and metric learning. In the ANN, we have several methods. We have the CNN, DCNN, all that. Now we have the deep learning. We are going in the deep learning next as the application of machine learning. So first algorithm is the deep learning methods. In the deep learning is a subset of machine learning that deals with algorithms inspired by the structure and function of the human brain. Deep learning algorithm can work with an enormous amount, both structured and unstructured data. Deep learning's core concept lies in artificial neural network, which enable machines to make decisions. The major difference between deep learning versus machine learning is the way data is presented to the machine. You can see in the figure that how the input layers and hidden layers and output layers make the structure of the deep learning. Machine learning algorithm usually require structured data, whereas deep learning network work on multiple layers of ANN. This is what simple neural network looks like. This is one of the network has an input layer that accepts input from the data. The hidden layer is used to find any hidden feature from the data. The output layer then provides the expected output. Here is an example of a neural network that uses larger set of unlabeled data of eye retinas. The network model is trained on this data to find out whether or not a person has diabetic retinography. So can see through this deep learning algorithm, you can identify it. Then this is the basic structure how the deep learning work. Calculate the weighted sums. You can see in this one here, the calculation of the weighted sum. Here we have the inputs, and then we compare through activation function, and then we get the output. So calculate the weighted sums. The calculated sum of weights is passed as an input to the activation function. The activation function takes the weighted sum of input as the input to the function, adds a bias, and decides whether the neuron should be fired or not. The output layer gives the predicted output. The model output is compared with the actual output. After training the neural network, the model uses the back propagation model to improve the performance of the network. The cost function helps to reduce the error rate. So this is the model how deep learning work. Here you can see the extended figures. You see these are the inputs. Here we have the weighted sum. Then we compare it and compare predicted output with the actual output. So then we have this is the cost function. If you want to further optimize it, you can compare it. In the following example, deep learning and neural networks are used to identify the number or the license plate. This technique used by the many countries to identify rules violates the speeding. So this is another example how you can detect through deep learning. So there are types of deep neural networks. So one, we have the convolution neural network, that is the CNN. CNN is class of deep neural networks mostly commonly used in the image analysis, CNN. Then we have the recurrent neural network. that is called RNN, uses sequential information to build a model. If often works better for models that have to memorize past data. Then we have generative adversarial network, GN, or algorithmic architectures that use two neural networks to create new synthetic instances of data that pass for the real data. A GN trained on photographs can generate new photographs that looked at least superficially authentic to human observers. Then third category, we have deep belief network, that is DBN. DBN is a generative graphical model that is composed of multiple layers of latent variables called hidden units. Each layer is interconnected, but the units are not. You can see machine learning versus deep learning comparison here is made. The machine learning, you see the factors: data requirement, accuracy, training time, hardware dependency, and hypermeter tuning. So these are the parameters. So you can compare both the algorithm. If you apply the deep learning algorithms, so deep learning requires larger data, whereas the machine learning algorithms can train on less data. So this is the advantage of the machine learning. The second, provides high accuracy, gives lesser accuracy. So if you need very high accuracy of the micro level, then you need a deep learning algorithm. Takes longer to train, takes less time to train. So time, if you want fast, then you have to go to the machine learning. Requires GPU to train properly, so you need the graphical, then trains on CPU. Can be tuned in various different ways, limited tuning capabilities. So these are some pros and cons of these two, means deep learning and the machine learning. However, both are very useful depending on the requirement. So through these algorithms, we can handle the various types of problems. You can see through the machine learning and the deep learning algorithms, we can have the mathematical modeling, we have the classification, we have the clustering, and then we have the forecasting, vector quantization, pattern association, control. Then we can have the optimization, power quality analysis, load scheduling, image processing, medical image feature extraction and analysis, and advanced medical image feature modalities. So these are the various types of the problems as well as applications of these algorithms which has been discussed. Now for these we have the computational methods. Through computational methods we have soft computing. If you go, we have ANN, CNN, fuzzy, and genetic algorithms. So these are the four techniques through soft computing. If you go to machine learning, data analytics, deep learning, AI, conventional AI to computational intelligence. So the latest one we talk about the conventional AI to computational intelligence, means the purpose of AI is to make the intelligence in the system. So conventional AI to computational intelligence. Now we will be discussing case study. We have 4 case studies I have incorporated in this presentation. गार्गी टाइम कितना और है हमारे पास अभी?
सर टाइम अब
चलिए मैं 1-2 केस स्टडी कर लेता हूँ अभी तक. अगर किसी कोई इसमें अब मैं अभी तक तो मैंने मेथड्स इसका डिस्कस किया है. नाउ एक्चुअल एप्लीकेशन और केस स्टडी में डिस्कस करूंगा. तो अगर किसी को कोई क्वेरी हो तो बता दीजिए, फिर मैं केस स्टडी पे आई विल 10 मिनट्स में मैं आपका केस स्टडी के 2 कम से कम खत्म कर दूंगा, जैसे कि आपका ओवर टाइम, क्योंकि आपके लेक्चर मैनेज करने होंगे आपको और भी. तो लेट अस हैव द केस स्टडी 1, detection and classification of chronic pulmonary disorders through CXR using deep learning approach. So first, through deep learning approach, we going to discuss this. What we want actually, we want to detection and classification of chronic pulmonary disorders through CSR using a deep learning approach. So is here we have, you can see that this is the basic structure of the proposed classification model. अभी मेरा लेक्चर 10-15 मिनट चलेगा, 15 मिनट्स और लगेगा, ठीक है, जब तक आप वॉक ले लो एक इधर। हाँ, so lung related ailments are prevalent all over the world, which majorly includes asthma, chronic obstructive pulmonary disease, tuberculosis, pneumonia, fibrosis, etc., and COVID-19 add to this. So first problem, you can see that is called the pulmonary disorder. So in the first two lines, we have clearly told that what are the pulmonary disorders. And also the COVID-19 was a big disaster for the world, in which these the medical image processing was playing a very key role to analyze the corona through these methods. WHO had identified cancer in the lungs as a fatal cancer type among others, and thus the timely detection of such cancer is pivotal for an individual's health. Since the elementary CNN have performed poorly in identifying typical image types, hence we recommend a framework with the deep learning approach for the recognition and classification of chronic pulmonary disorder for the COVID-19 particularly. Here in this work we have published a very good paper in the Elsevier. So that this is the basic model of the proposed method through deep learning. You can see that we have the raw image data. Then we identified the region of interest of the image, and then data set division. Then we classified it normal and infected images. So the first normal, we have fine-tuned DCNN model 1, and then we have infected fine-tuned DCNN model 2. And through this we classified that normal and infected. Then we had COVID, and we had after 10 minutes I have lecture COVID and other diseases through this model 2. So these were some of the results find out through this DCNN. The image set utilized for carrying out the proposed reservoir is from a data set available, in which we have 5,606 chest X-ray images, in which 1471 images are taken from the evaluation of the proposed deep learning framework. You can see from the figures. These are the actual images from where this is the we have classified the infected and the normal data. Here is the detailed classification, and here you can see that average area of CPD infected patterns. It is given here. So this is how the this is the image pre-processing. Very simple, everyone knows it. And this is the histogram. This is the extraction of the features through deep learning. These are the stages given. You can see that. So in this proposed work, the information of the model that is trained for the classification of basic images is employed to explain the classification of chronic pulmonary disorder. First, dense convolutional neural network, that is DenseNet 201, is a pre-trained deep learning network, and as per its name, it had 201 densely connected layers. DenseNet is somewhat a logical augmentation of ResNet. Firstly, the DenseNet 201 network is initialized and is set up for fine-tuning. The network is thus represented implying weights that are previously trained over ImageNet, while the fully connected layer is left off. Starting from the point, a new FC layer is designed that contains a flattened layer, dropout, and dense activation layer for the classification of CXR is in the both models. The detailed layers structure of the proposed fine-tuned dense net model is presented in this figure. You can see here the experimental outcomes of this activation of the first convolution layer, maximum activation with this first layer. So you can see here identified first figure A highlighted for A and B COVID and CD pneumonia infected CXR image. So these are some graphical representations of the training accuracy of model 2, that is classification of COVID-19 pneumonia and other CPD CXR images. And in the figure 15a, you find that this is the confusion matrix, that how the accuracy of the algorithms takes place. These are some numeric data you can see. So by using this algorithm, first table shows the analysis of confusion matrix for model 1, in which we have the infected normal TP, that is true positive, recall, specificity, precision, error rate, accuracy. So we have analyzed these 6 features of the image, that is recall, specificity, precision, error rate, and accuracy. So overall accuracy we got 96.8%. In the table 2, we have collective performance measurement for model 1. So in which we have the infected and normal. So in which types G mean, various methods we have used. Then in table 3, analysis of confusion matrix is over here, and in table 4, collective performance measurement for model. So this is the analysis, quantitative analysis. You can see here in this, this is you can see here that receiver operating characteristics ROC, as well as for both the cases, for classification model 1 and for classification of model 2. So you can see it is highly accurate system. So if we compare with the standard existing methods, so the proposed work got 96 point model 1 8 and model 2 96.8%. Then we have classification of brain tumor in another paper using deep learning. So these are the, you can see the MR images. So
you are speaking with has put your call on hold. Please stay on the line.
Then we have the, you see the proposed method here, the proposed structure of the deep learning system. We have brain proposed algorithm. So this is the proposed structure of the deep learning model. Another case study 2. This is pre-processing stage. This is transfer learning and feature extraction. You can see here, load pre-trained network, then replace final layers, and then we have trained network, predict and assess network accuracy, and deploy results. So these are the stages of this transfer learning method. You can see here the 2 nets are used. First one, the AlexNet architecture for this purpose, and another one is a GoogleNet architecture. Then we have next one is the ResNet architecture through deep learning, and then we have super SquareNet architecture. So these are the results of this method. Same way we have analyzed various parameters. And then we have the training progress, you can see over here. And these are the results, or you can say the accuracy of our algorithm. So we got 99.04% through this method. You can see the highlighted portion here, over here. Then the case 2, ये डिस्कस कर दिया है मैंने पहले ही. Then last one is the this is the COVID-19 through CXR using texture feature analysis and ANN. In this you see the COVID cases. This is the basic algorithm, proposed classification framework of feature analysis and classification through ANN. Data set and pre-processing. So here you can see the pre-processing results. These are the extraction of GLCM based features. This is the basic architecture, results of this method. So these are the you can see matrix of confusion for the proposed network and the receiver operation characteristic of the proposed network. And this is the error histogram. Then this is the comparative data, working of the proposed system in medical situation. Present the application part of the proposed model, how it can be implemented in medical situation for identifying COVID and other pulmonary disorders. These are the research papers you can refer. They are available on the net. They are our own publications through which we have presented the case studies, and these are few references you can refer for further study. This is Gautam Buddha University. These are my students and infrastructure. Thank you very much. So Gargi ji, मेरी तरफ से जो है I have concluded the session. So please, if you have any questions, anything, kindly ask, please.
Thank you so much, sir.
I think there are no questions from the participant side. Thank you so much, sir. For,
Please pass on to the
side.
audience. I am sorry that the both way there was, because of I was afraid in the beginning itself. I told you that Microsoft Teams sometimes create problem at the 11th end, because
yes, sir.
You see, Gargi, I had 3 FDP ATAL in 2021 and 22 after COVID. And in MS Team, we had a lot of problems. So we switched to, I bought the Google account, then I had all the, because in Google, we have limitation of, I think, 100 or something numbers. More than that, we cannot have joined the. So we bought the Google account. So we, at that time, it was 200 participants were permitted. How many participants permitted in your FDP?
Sir, currently we have 164 participants.
Now physical mod, we are also doing one that last 15 days ago, there was limit of 50.
No, sir, this is not there, I think.
So this is an online FDP. We have
how many participants today?
Our voice is not going to search, and
really
actually we have switched on a phone
okay,
also.
Fine.
Sir, today we have 164 participants.
Acha, hello.
Sir, I think.
अच्छा, ओके, कोई तो क्वेश्चन हो अगर तो बता दीजिए किसी का, फिर मैं इसको.
There is no question from the participant side, as we are just going through the chat.
कोई कुछ नहीं पूछना चाहता है?
To write questions in chat box, if any.
Hello. Yes, please. If anyone has question. गार्गी, अभी आवाज आने लगी थी बीच में, मैंने जैसे अभी देखा था.
Sir, are we audible now? Are we audible now?
हाँ, मुझे आपकी आवाज आ रही, बहुत साफ आ रही है
Yes,
आवाज।
sir. Yes, sir. Thank you so much.
Start.
Sir, as we are going through the chat, there is no question from the participant side. Participants, if you want to ask something, please share in the
गार्गी जी
chat
आवाज
or
आ
you
रही है
can
मुझे?
raise your hands.
हाँ गार्गी जी, अब मुझे आवाज आ रही है मैम, राखी मैम की पूरी आवाज आ रही है, और अभी तक पूरे प्रेजेंटेशन में क्या ये था, क्या मेरी समझ नहीं आया, व्हाट टेक्नोलॉजी वाज दिस। रियली मैं भाई मैंने 50 लेक्चर लिए हैं ऑनलाइन, आई एम रियली सरप्राइज्ड दैट दिस हैपेंड टुडे। अच्छा कोई नहीं, हम उसी पे बात करते हैं चैट पे। हाँ तो इस पे जो है जी, तो हाँ जी, कोई क्वेश्चन हो तो प्लीज पूछ लीजिए आप लोग, और इफ एनीवन वांट टू डू
Yes,
रिसर्च
sir.
पीएचडी।
We will convey.
Yeah, thank you Rakhi ji,
Thank you
and
so much, sir.
thank you for the invitation, and
Thank you so
we
much.
congratulate the whole team for organizing such a great activity for AICT sponsored ATAL FDP and medical imaging. We welcome you all. We have an international conference here in Gautam Buddha University in January. So if anyone willing to join it, though paper submission date is over, but still if anyone one or two papers we can consider with the recommendation of Dr. Gargi Mishra, if anyone wishes, we can have. So thank you everyone for inviting. Thank you so much.
Thank you so much, sir, for accepting our invitation. Thank you so much, sir.
Thank you.
Uh,
So may I leave the session?
yes, sir. Thank
Okay,
you.
thank you.
Let us now proceed for the session 2 of day 4, Generative AI for Telemedicine by Mr. Yuvraj Kapoor, Senior Architect, RAN Solution Applied R&D, Nokia Solutions and Network. Mr. Kapoor is having 17 years of experience in radio telecom industry. Sir is currently managing RAN product automation and design. Sir, it gives me immense pleasure to extend a warm welcome to you for this session. Over to you, sir. Yuvraj, sir, you are there?
Yeah, hello everyone. Can you hear me?
Good morning, sir. Welcome, sir.
Good morning, everyone.
Yes, sir, you are properly audible. You can share your screen, your content.
Thank you. Yeah, I'll do it right away.
Good morning, sir.
Good morning, ma'am.
Dr. Jolly, yeah. Yeah.
Yes, sir. Visible, sir. Your screen is visible.
Okay. Shall we start, in fact?
Yes, sir. We can start.
In fact, yeah, I'll start with a brief introduction of myself. I'm Yuvraj Kapoor. Uh, I'm working as a senior architect, RAN Solutions, in the applied R&D department for Nokia Networks. RAN means the radio access network for the wireless technologies, be it like when I started my career, it was like 2G. Now these days we are working on more of 5Gs and 6Gs. So for the last uh, 11 years, more than 11 years, in fact, I've been associated with Nokia. I started as a optimization engineer, and these days leading the RAN automation portfolio. So here in Nokia, being primarily into the telecom industry, we indulge in the use cases related to operations, analysis, dashboarding, troubleshooting of the live networks, be it across the globe. In fact, I've been last few months. In fact, I've been working on various networks, starting from some of the ones in ATAL Africa to Nordlys Denmark to Saudi Telecom to Orange in Australia to diverse parts of the world, in fact. So various networks have their own challenges, and those guys, those people, those projects, they come up to us asking for different automations that can help uh, mitigate the difficult parts or the repetitive parts of the job in their day-to-day operations. So this is where we come in and we try to automate all those stuff. So that not only telecoms, we also work on the few of the use cases of IoT in that from that maybe from diverse backgrounds. In fact, starting agriculture, smart cities, maybe it medicines, apart from the telecom. In fact, so it involves people from diverse backgrounds like subject matter experts, architects, database specialists, developers, UI designers, testers, data engineers, data scientists, and whole lot of stuff. So we work with all these people and try to stitch a solution that can cater to various diverse use cases. So as far as I'm concerned, in particular, my association with the Bharati Vidyapit stands back in from 2012, I suppose, when I first came and to your Paschim Vihar campus, and I delivered some of the telecom-oriented technology trainings for the electronics and communication department, I think. So since then we have been associated with you, and it's in always be pleasure to be here and interact with you people. So coming back to today's topic, that is Gen AI in healthcare. So Gen AI being a smaller subset of the broader AI, in fact, uh, Gen AI is different from the broader AI. In AI, we use the large set of training data and the uh, whole lot of other data to generate different patterns, to predict outcomes, and lot of stuff. But in Gen AI specifically, we do not only predict, but we can generate new images, we can generate new patterns, in fact, based on the same set of training data. But here, the difference between traditional AI and Gen AI is those predict and relate to the training data set and work on the big large volumes of data. Here, the same training data set and the volumes of data, they can create newer uh, trends, newer pictorial things, and give you answers to a query on the go. In fact, the most popular of like there are 8, 10 different Gen AI platforms that are being used today these days. Uh, the most common of them is ChatGPT, for example, the OpenAI thing. The second one is Google Gemini, previously called as Google Bard, and Microsoft Bing, for example. So these are the most common couple of them. So these are uh, openly used in various industries, including telemedicine in our telecom as well. So let me start by introducing what exactly, how can we use this in telemedicines, and how I will not go into the deeper details and obviously the simulations and everything, because obviously 1 hour and a half hour is relatively a small period to in fact go into the technical details. I will uh, limit myself to more into the theoretical part and glide you through the use cases, what where exactly we can improvise, we can use AI, and what all use cases we can try and automate to bring more synergy, to bring more ease and efficiency, in fact. So let's start. So as you can see, in Gen AI, for example, when the topic is Gen AI in telemedicine, let's talk about telemedicine first. So what is telemedicine? Telemedicine actually came into being when uh, starting from majorly from the COVID-19 thing. So when the COVID-19 pandemic was there, it accelerated the adoption of telemedicine. Means there is no need to physically visit the doctor or visit the clinic or the hospital. You can get your prescriptions, you can get yourself checked uh, from the comfort of your home. That reduces the burdens on the hospitals as well and your pocket as well, and gives you flexibility to in fact get diagnosis and treatment from anywhere. So The healthcare industry overall faced a lot of challenges when it comes to telemedicine, because that is the reason why we it gave rise to telemedicine, because there were a lot of challenges. The challenges include uh, rising demand for personalized messages, personalized medicines. In fact, for every particular person, there can be a individual use case or individual type of prescription that may not suit the other individual. The protection of privacy of the individuals, because I don't want, as a person, I don't want my medical data to be visible to, or other people to have access to my medical data. In fact, rising health costs, ensuring high quality care, global shortage of healthcare workers, chronic disease management, and overarching goal to improve diagnosis accuracy. Furthermore, there are medical errors that are preventable, that can occur during medical care. These represent a major public health issue and are the major causes of mortality, like deaths. Healthcare professionals can commit a range of mistakes, including uh, incorrect blood transfusions, misdiagnosis, and some. There have been cases like there have been uh, under treatment or over treatment, surgical mishaps.
Yuvraj sir,
Yes,
sorry
ma'am.
to interrupt you. Are you changing your slides?
I'm currently on this one. I'll go ahead and do that.
Okay, 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 okay. Thank you.
So these all are the reasons for given mortality rates and even deaths. Uh, Additionally, the healthcare sector is undergoing numerous technological evolution. In the rapidly changing digital age, the fusion of technologies like AI with medicine, it has given rise to innovative solutions that can be applied in clinical settings. The application of AI in healthcare has been a significant surge over the last few years. Basically, as I told you, starting from major surge has been starting from when the COVID pandemic came in. The advent of AI holds immense promise for enhancing healthcare outcomes, including lowering costs and expanding access. As a revolutionary technology, AI, it has the potential to refine medical decision making, clinical diagnosis, and treatments. It can have various applications, starting image based diagnosis in radiology, in ophthalmology, in pathology, in dermatology, and even in genetics. In fact, interpretation of genomic data, in fact, clinical forecasting, and so on, including robotic surgeries, in fact. So this is one of the use case we have been working on. For example, when it comes to robotic surgeries, so the main parameter apart from the trained robot is uh, a doctor from very far should be able to collate with that particular robot, and there should be no latency. As per the current 5G networks that we are in, uh, we have achieved a latency in the networks of or less than 10 milliseconds, in fact, less than 5 milliseconds, in fact. But for a surgery to be very accurate, we need the latency in tunes of less than or around 1 millisecond. So our teams are working on such things where we can bring down latency. So going forward, before even 6G, uh, we can have solutions around cloudification of the radio network, which can further bring down the latency. So these are the various use cases, in fact, we are working on. So Gen AI, it can be applied to various areas, including clinical documentation, medical education, evidence-based medical summarization. For example, as I told you, for example, whenever you go to a hospital, in fact, you are given a hell lot of paperwork to make your signatures in, and you hardly go through that. So you are forced to make your signatures in a random number of places, and these can be automated. You can, before going to the hospital for admissions, you can actually log into an app provide your consent, give one signature, and go on. There you will be having much more better environment. You can go through the terms and conditions on whatever is written. When once you are in the hospital, you hardly find time, or there's hardly time to actually go through those documents. You simply sign and go ahead. So these all processes can be automated, as these are the redundant processes that happen with every individual at the time of admission, more or less. So, any which case, let's come back. So, let's start with the slides. So, here we will take every step one by one. But all the technologies are used in Gen AI, or in fact, in the broader general AI, or the traditional AI. So, we'll come there. So, yeah. Yeah. So, in Gen AI in telemedicine, we talk about the role of generative AI. The generative AI has been revolutionizing. In fact, there has been a very big impact in modern telemedicine of AI. It has been revolutionizing modern healthcare by easing the processes and improving the outcomes. In fact, be it uh, removal of the repetitive tasks, or generation of more accurate analysis, and maybe the patient outcomes. In fact, there are various use cases. Some of them are listed here. For example, let's take them one by one. One is predictive analysis. The AI algorithms analyze patient data to predict health risks and outcomes. Because if we have a large volume of patient data, in fact, ranging from different X-rays to different prescriptions, various other documentations, in fact, we can use Gen AI to collate those data and provide uh, insights into a patient's health history. These algorithms, they enable proactive care. They help to predict health risks and outcomes for different patients. There are various predictive models that have reduced that they have been different models that have reduced the hospital readmission rates to up to 30%. In fact, second, diagnostic assistance. AI tools can assist healthcare professionals in diagnosing diseases more accurately and quickly, reducing human error. By integrating AI diagnostic tools, we have reports, or we have studies that it has led to around 28% increase in diagnostic accuracy. In fact, personalized treatment plans. AI analyzes individual patients' data to recommend tailored treatment options. For example, one patient need a particular type of treatment, and other patient needs uh, other particular type of a treatment. For example, one patient goes to a doctor, but he has high diabetes. The other patient may not. So the mode of treatment for both of the patients will be different. So these can be tailored. That can be tailored made, in fact, using personalized AI algorithms, and that leads to enhanced effectiveness. AI-driven platforms that can create personalized treatment plans, leading to better patient treatments and healthcare outcomes. Then comes operational efficiency. AI automates administrative tasks, as I told you already, such as scheduling, billing, the documentation at the time of admissions, allowing healthcare providers to focus on the patient care, uh, and streamlined operations. In fact, we can deploy more resources, in fact, in the patient care rather than administrative tasks. So next comes remote monitoring. AI powered devices track patients with health metrics in real time. For example, you have seen there have been a lot of wearables or diabetes patches or a lot of stuff that has been used these days. These AI powered devices, these can track patients in real time, providing alerts if needed for any concerning changes. This has enabled, in fact, the healthcare professionals to enhance patient monitoring, leading to uh, timely interventions and better health management. In fact, because we can intervene before the condition worsens at the start, or at the, uh, for example, the AI algorithm or the AI variable that predicts a certain spike in some of the parameters. You can there and then contact the patient and start the treatment before it worsens. Then comes virtual health assistants. AI chatbots are there, and virtual assistants. These can provide you basic information and immediate responses for your queries, improving access to information. Because obviously, uh, most people like you and me, when we have certain condition or we are looking for a treatment, the first thing we go to is Google it. So, and let me tell you, that is the root cause of half of our illnesses, in fact, because Google can provide you with a lot of indications that, okay, if you are having this, you can have this disease. And once you go through that, you will actually finding yourself having most of the diseases, in fact. So, coming back here, enhanced imaging analysis. AI algorithms can use, as in the previous session, Mr. Ansari was showing the different X-rays and everything. Uh, those can be analyzed, MRIs, X-rays, this can be analyzed to identify abnormalities which can be actually missed by a human eye. Because every doctor, every individual, or every practitioner, in fact, has his or her own way of judging or reading things. By leveraging AI imaging tools, we can actually provide more standardization to the treatment or the readings. So it gives us more improved diagnostic speed as well as accuracy. Then comes remote patient monitoring. AI systems can collect and analyze data from wearable devices, I already told you, allowing for continuous monitoring of patient health. It can empower to proactively manage chronic diseases like high BP or diabetes, having sugar spikes at random intervals. These these algorithms that have actually led to close to more than 20-25% decrease in emergency visits to the hospital. Then comes telehealth platforms. Gen AI enhances telehealth platforms by providing features like automatic scheduling, symptom checkers, personalized health recommendations, and these sort of telehealth medicine. For example, you can check which doctor I can see, who is the best specialist in town for this particular purpose, when I can see him. You can plan your visits, you can schedule your visits, and you can interact with the chatbots, or you can get a gist of what exactly the problem is. So then comes the data driven insights. As I told you that we have various patients' data in various forms, some in the forms of X-rays or MRIs or scans, some in the form of different like prescriptions, or some of the other medical notes by the doctors, in fact. So AI, what it does, it compiles all that stuff into meaningful insights. And whenever you go to a doctor, a new doctor or something, for example, you had a surgery like 10 years ago, but all your medical records are available at one place. What AI can do, AI will compile all this information and provide the current doctor with the insights of your health history, collating data from different inputs at different intervals. So it has led to improvement in better healthcare or effective healthcare, maybe in the range of more than 20%, in fact. The evolution of telemedicine with AI not only makes it accessible to more people, but also makes it effective. But all things are can be used in AI can be used in telemedicine, in fact. For example, these all the enhanced patient care, that means timely diagnosis, personalized treatment, predictive analysis. Accessibility can be increased because, for example, so you and me are living in Delhi NCR, we are having relatively better healthcare facilities for compared to somebody who is living in remote areas, for example, somewhere in remote areas, hill station somewhere. So if we have AI-oriented chatbots or AI-oriented solutions, these facilities can be extended to those people there as well, irrespective of where they are located. That's the sole purpose of moving towards the telemedicine rather than the traditional medicine. In fact, increased accessibility that, for example, leads to remote consultations, 24 hours availability, and the most important of them is like language transitions. For example, somebody cannot interact to the doctor in the language of that the doctor understands. For example, somebody from South India comes to North India maybe for treatment or anything, but obviously they cannot communicate properly with the doctor. Here, using AI, we can effectively communicate because uh, we can we can use the language translation facilities in the AI tools. Reduced operational costs. For example, we can, as I told you, we can automate the redundant tasks, automated scheduling, resource optimization, fraud detection, etc. That leads to improved patient engagement. Patients can engage on the platforms like chatbots and everything to get insights what are the symptoms, how they can, uh, apart from the medicine, what exercise can they do, and obviously our feedback systems. Their healthcare individuals can have feedback systems and uh, continuous health monitoring using wearables and other patches sort of AI tools. So these are all the use cases, different use cases that AI can be used in the telemedicine. So why there was a need for telemedicine, and in fact afterwards a uh, need for AI in telemedicine. So there have been a lot of challenges, in fact, in when it comes to the traditional healthcare, because obviously we have very high population already, and the number of patients are increasing day by day. So increasing patient demand is one of the reasons. The growing population and obviously the aging demographics uh, are the one of the biggest reasons to put pressure on the traditional healthcare systems. Whenever you go to hospital, you can see huge rush around. Patients these days especially, they expect faster, more efficient services, which traditional systems often struggle to provide. AI can help people meet this demand by automating routine tasks or redundant tasks, as I told you already. Second is rising healthcare costs. With the inflation is too high, and the inflation in healthcare is twice the regular inflation. In fact, the healthcare expenses continue to escalate, uh, making it essential, in fact, to find cost-effective solutions. AI can optimize resource allocation and reduce waste, leading to significant savings. In fact, to optimize costs means we can allocate suitable resources wherever needed. For example, we don't need people to give you forms to sign and check that. That can be automated. There can be reduction in the manpower related to administrative tasks. Third is workforce shortages. That is a global phenomena. In fact, when it comes to healthcare, most of the healthcare systems face shortages of qualified professionals, particularly in uh, primary care and nursing. In fact, AI can assist in this by automating administrative tasks and providing decision support to clinicians, allowing healthcare providers to focus more on patient care rather than paperwork. For example, if you go to any even ICU or anything, you can see it yourselves because the nurses around are half of the time, in fact, they are taking care of the patients, and half of the time they are managing the paperwork. So those paperwork thing can be automated so that it reduces burden on the nurses and they can provide more time to the patient. Third being quality of care improvement. AI can enhance diagnostic accuracy and treatment recommendations, leading to better results. Continuous monitoring through AI tools can help in early detection of complications. AI-driven analytics can provide insights into best practices and areas for improvement. Obviously, there are a lot of medical data that is available around the globe. With all this big data, this all data into the our uh, AI tool or AI algorithm, we can have we can search for relevant solutions about the recent advancements in the particular field, or what are the current best practices followed in the one of the better places in the world where the healthcare systems are in fact better than us. So we can elevate the quality of care, so resulting in better healthcare delivery and better satisfaction. Then comes fragmented care delivery. What do you mean by fragmented care delivery? In fact, can anybody say something on that? So whenever we go to whenever we go to hospital, in fact, we can see that different healthcare functions, they work in silos. Silos means they work in different clusters. Everybody will tell you, okay, you have to get this test done, go in that building on in that department, get this test done and come back. Okay, you have this, go to a particular doctor, this particular department, get the test done and come back to us. So this is how they move you places. So this is how we want to have better interoperability instead of these things working in different fragments. Most of the healthcare systems operate like this. Uh, AI can facilitate better communication because obviously you have tests, you can put it across in a health record, and it can transport, it can be seen, it can be accessed by various departments. You need not move from one department to the other. AI can analyze uh, like the different reports for better communication and data sharing among various departments, creating more integrated care model. In fact, improved interoperability can enhance coordination, and when it comes to patient care, it can provide better care. In fact, then comes data overload. Healthcare providers, for example, doctors are burdened with vast amounts of data. For example, you have a hell lot of scans, hell lot of test results. So to assimilate everything on the go, to understand everything on the go, and for more than understanding, to remember everything on the go is is a big task. So it is very difficult for them to remember each and every patient and uh, their medical records. So AI, whenever you visit a doctor, suppose the doctor can click on your profile and get a gist of your medical charts, medical data on the go. He will be able to connect you with you better and provide you better recommendations and better uh, treatment. In fact, so AI can provide the analyze the large data sets, identifying patterns or different trends that may not be available, may not be visible to human eye. So this capability can support decision making and improved patient care. Then comes to the next point: inequalities in access. Disparities in healthcare persist, particularly when it comes to different communities. For example, as I told you already, we are in the capital of India. We have one of the better healthcare infrastructure around. But imagine somebody in tier 3 city of maybe a Jharkhand or Bihar or even remote places. Those people may not have the access, similar sort of medical access. So if we are providing them with AI integrated solutions, for example, chatbots and these things, so even their providers can take cues from the best practices or from the best doctors around here, and can lead to better healthcare for them as well. Then comes regulatory and compliance. This regulatory and compliance is uh, not much of an issue when it comes to healthcare in India, but it is a very big thing when it comes to healthcare out of India. In fact, many of the countries. So we'll not touch it here because obviously whenever we go to the doctor, we doctor or the hospital for admissions, we anyways will have to sign a hell lot of documents. In fact, so then comes limited preventive care. So as you know, we can see whenever we have certain issues, then only we go to the doctor. Okay, doctor, I have this condition. What can we do now? But this is what you call uh, I will say this is not preventive healthcare. In fact, this is reactive healthcare. So when it comes to preventive healthcare, we know that we genetically have this condition. If I do regular exercise, I may not get this disease. I may not, if I do this particular sort of treatment, I can take this medicine regularly, I may not have this disease. So this type of preventive care, this can be provided using different sort of uh, AI algorithms that can work on a person's profile, working on genome data, for example, and different test results, histories, and everything, and provide you insights. Okay, you have probability that uh, going forward that you can have this particular disease or this particular condition. So if you do this, that can be uh, avoided. In fact, so these things uh, can be done using AI. These are which is currently not possible using the traditional healthcare. So, what are the current benefits? What are the benefits of Gen AI in telemedicine? In fact, we have discussed most of them. I'll go over in the one-line definitions or one-line discussions again. Maybe generative AI is currently the transformative force in healthcare, addressing many of the limitations. Like, for example, you can see a few of them here. Enhanced diagnostic accuracy. AI algorithms can analyze medical data and images, improving diagnostic precision. Uh, there are various machine learning models that can identify patterns that can be missed by humans, leading to more accurate diagnosis and better patient outcomes. Then comes personalized treatment plans. As I've already discussed, different patients can have different conditions. Suppose two patients go to a hospital with the same sort of illness, but the medical conditions of both the patients can be different. So one might be having a high diabetes, or one might be having a high blood pressure, maybe. So the treatment to both of the patients cannot be same. That has to be tailor made or personalized. Gen AI can analyze patient data, all the vitals, in fact, to recommend tailored treatment options based on the individual health profiles. This personalization can lead to better patient outcomes and satisfaction. 24/7 availability. Obviously, leave aside Delhi, but obviously in most parts of India, uh, one of the better healthcare facilities are not available 24/7. So, if you have certain condition or certain issue, you rush to the hospital and straight away go to the emergency. So here, before going to the emergency, you can actually engage with the doctor or healthcare expert or even a chatbot to or the virtual assistant. These can provide you immediate responses at any time, maybe at the middle of the night as well. This constant availability can help triage patients. When you triage means triage means patients who have some critical condition. They means they need treatment in a priority compared to the others. It's maybe triage patients may have a life threatening condition or something, but others may not. So triage patients are those patients who need critical treatments at an emergency. In fact, so this constant availability can help even the triage patients. Okay, for example, if you have a certain condition, the chatbots or the virtual assistant can give you, okay, you do this in the meantime, and so that it can get you stabilized, and parallelly you can go to the hospital. So it can buy you time. The instructions or the commands given to them by the chatbots or the virtual assistants can provide them help in gauging more time to stabilize people at that particular instant in time as well. So that can help a lot. Then we comes to scalability. For example, we all have seen the scalability issues when the COVID-19 thing was around. Uh, we could see everywhere that there was no place in the hospitals, any of the hospitals, in fact. So, and everybody wanted to be in the hospital at that one particular instant in time. So that's when the scalability comes into being. So generative AI solutions can handle large volume of data, of patients' data, in fact. And instead of putting everybody to a hospital, they can provide you with better healthcare plans, making it easier for to scale healthcare services. This scalability can help address the shortages in healthcare professionals, as for example was the case during the COVID, especially in remote areas as well, thereby improving access in telemedicine and in case of certain pandemics like COVID. Then comes predictive analysis. This is the one of the uh, most important aspects of AI in telemedicine, in fact, because with major aspects where traditional medicine lacks is predictive analysis. We can have analysis of a lot of patients' data, including the genome analysis and hereditary analysis, uh, to predict potential health issues before they arise. Early intervention, for example, that can lead to better management of the chronic diseases and overall health, ultimately reducing healthcare costs and obviously mortality rates. Right. So going forward, how Gen AI powers telemedicine? What all the technologies are used, and what are the different use cases here? Some of the technologies used here are, for example, the first one is natural language processing called as NLP. NLP enables machines to understand and interpret human language, facilitating what you can say better communication between patients and providers. Providers means healthcare providers. It can be used in chatbots to answer patient questions, and obviously that can lead to multilingual communications. For example, I don't know Hindi or I don't know English. For example, I need to communicate to a chatbot, but this NLP can be used as a multilingual channel, but then I can chat in one language, and the chatbot can reply back in any of the language which can be translated to my language which I understand better. Then it comes to machine learning. Machine learning algorithms can analyze a vast amount of healthcare data to identify trends and decision making, improve decision making. These algorithms continuously learn from new data. Obviously, the machine learning algorithms they uh, learn. The more they work on the data, the more accurate they get. They increase the accuracy, enhancing their accuracy over time and providing healthcare providers with actionable insights. Third is remote monitoring tools. There are various tools like AI-powered devices that can monitor patients' vital signs. Uh, for example, there are the glucose patches that different people use, and for example, some heart rate uh, trackers that can be given to individuals. They can monitor different vital signs and health metrics in real time. In case of some anomalies or abnormalities, uh, these can provide alerts to medical or healthcare providers for any concerning that changes. This continuous monitoring can be crucial, especially in the treatment of chronic conditions. For example, if we can have timely interventions, we can cure better. If we have delayed intervention, suppose you have some condition now, you take like 1 hour to bring that patient to the hospital, the condition may worsen or may be out of control by then. So if you can provide timely help, that is always better. Third is telehealth platforms with AI integration. There are many healthcare platforms or telehealth platforms that are now available that can improve workflows and patient experiences. So you can have multiple, for example, a few of them you must be using already. For example, one is Practo or something, where you can choose the doctors in your town. You can go through their ratings, number of years of experience, expertise. You can automatically schedule an appointment, follow-ups. There are different applications as well. For example, you can get patient reminders. Uh, you can reduce these administrative tasks, and for example, the doctor will not need much of the staff to actually uh, do all these course. They can actually focus on the patients and their treatments. Then comes data analytics. AI can analyze patient data to provide insights into population health as a whole. When it comes to community health, in fact, there are certain parts of certain communities that are living in, for example, maybe far-flung Ladakh or far-flung um, Port Blairs or something, which cannot get similar sort of healthcare access that you and me do. So reading their records, their medical records, and analyzing them can provide you better insights into the population health trends and obviously their treatment efficacy, so that government accordingly can plan what sort of health plans or health uh, uh, things can be planned for those communicators at those remote places. Then comes VR or AR augmented treatments. These VR or AR basically are more these days are more focused towards training of the medical professionals. AI can enhance VR AR applications for training healthcare professionals and providing, uh, for example, education to different patients. In fact, you can have go through various VR videos to learn about different um, patterns, and you can see a particular condition can worsen to what condition, and you can go into that. So these things can stimulate real life scenarios for better learning, better understanding, and improving the skills of healthcare providers as well as the patients. Then it comes the electronic health records. As I've already mentioned in a couple of places, that we already have very fragmented medical treatments. In fact, we can go for MRI or scans at one of the place, X-rays at one of the other place, for consulting the doctor or getting prescription at some other place. So getting this all, collaborating these all health records at one single place, uh, or getting all the information at a single go, at a single click, date wise and doctor wise or condition wise. For example, for you have a certain condition today, you get a lot of tests done. Maybe 6 months down the line, you have some other condition. You go to a professional or a doctor. He asks for your medical records. You can have all your medical records at one place. He can gauge that. He can analyze that, uh, and see. For example, some of the I recently had a condition in my family. So my father had to go to a doctor, in fact, but we had to go again to get some of the tests done because of this his high potassium in his body. He could not go to uh, go for a particular medicine. In fact, the medicine had to be changed. For example, if you have all your medical records ready with you, you can see, okay, this particular element is high in this body, you cannot take this medicine. This particular thing is low, you cannot take this medicine. So your healthcare professional can plan your treatment accordingly. So having all the information at one click, at one go, is always beneficial. So these are the few of the things we have already discussed. So delayed diagnosis, AI can speed up it and provide real-time diagnosis using chatbots and everything. Technology barriers, uh, we can have enhanced connectivity. You can connect with the doctor from the comfort of your place. Limited physical examination. So now we can have virtual physical exams using different AI tools, which can speed up the telemedicine thing. For example, previously we used to go to a doctor. Okay, I have certain conditions. Okay, take this medicine. Some other person will come with some other problem. I have this problem. The doctor will still give him the same medicine. Okay, go ahead, take this medicine. So there was more like generic treatment plans. So now, based on the conditions, based on the excess or deficiency of one or the other element in a patient, in fact, so we can have personalized treatments that can lead to better results. So now we come to machine learning telemedicine. These are the different tools of AI that are being used in various use cases. We are just going through what use cases are supported by what technology. Machine learning, it is revolutionizing telemedicine by enhancing the efficiency and effectiveness of remote healthcare for or the telemedicine, as we say. There are various use cases. For example, let's take one by one. Predictive analysis. Machine learning algorithms analyze patients' data to predict health outcomes, enabling proactive, in fact, interventions that can lead to reduced hospital visits and better results. We can tackle certain problem because of genome analysis or something before it actually gets in. Uh, Taming a particular condition or an illness at the preliminary stage will result in better results as well as very less costs. The second is personalized treatment. By examining historical data, we can have tailor-made treatment plans. Third is remote monitoring. Machine learning models process data from wearable devices, for example, that allows real-time monitoring and timely alerts. This capability or remote monitoring, this can lead to uh, reduced number of emergency visits, in fact, and obviously the associated costs. Decision support. We can assist healthcare providers, in fact, offering evidence-based recommendations using machine learning. With, for example, different scans, we can reduce diagnostic errors or improved patient care, ultimately leading to better health outcomes. And then resource optimization, as already discussed. Uh, AI solutions can help managing healthcare resources by predicting, okay, this type of patients inflow will be higher in this particular area. For example, in the recent like 1 week or 2 weeks last in Delhi NCR, this, for example, some AI models can predict, okay, in Delhi NCR hospitals, there will be increased inflow of patients related to lung diseases because of the pollution around. So these solutions can predict the patient inflows and then accordingly help the hospitals or the healthcare providers to optimize staffing solutions, staff allocations, because obviously I will need more staff according to this particular specialization. I can make sure I have this department has more staff because I can expect a lot more inflows in particular department. So that's leading to better healthcare facilities operate at peak efficiency and reduce costs, obviously. Then it comes, the second is deep learning. Deep learning can provide you assistance in image analysis. Deep learning algorithms can interpret medical images or texts or whatever. They can even access codes and everything. And then they can, in the analysis or understanding or interpreting, in fact, they can outperform obviously human radiologists in accuracy. This leads to faster diagnosis and reduced errors. Then comes to disease detection. Neural networks in the deep learning neural networks. They can be used to identify early signs of disease, such as cancer or other genetic diseases, or maybe like diabetes. That is more of the most common genetic disorder, in fact. Enable early interventions that can save lives and costs as well. Multimodal data integration. Multimodal data integration means, as I told you already, integrating various data types, images, genetic data, clinical prescriptions or data, or pharmacy prescriptions that you have taken. So these all things can be collated. Different deep type of data inputs can be provided to our AI models, which can provide a comprehensive view of patient's health, facilitating the healthcare professional or the doctor, in fact, to make more informed decision regarding a patient's health. Then comes the continuous learning. Continuous learning is always a feature of machine learning solutions. These solutions learn by experience. These systems improve over time as they are exposed to more and more data, in fact, enhancing accuracy over time and reliability over time, which translates to better care and providing more accurate results. The cost efficiency is obviously another feature, but that is a very generic one. Then we come back to NLP for improved patient communication. These are all the different use cases of NLP. For example, NLP powered chatbots we have already discussed. They can provide instant responses to patient queries, improving access to information, reducing wait times. Uh, then we can have sentimental analysis. Sentiment analysis. Uh, Obviously, we can analyze patient feedback here in the sentiment analysis. How satisfied a patient was with the treatment, or treatment given, or the help provided to them. Uh, this you can analyze or gauge patient concerns and improve your feedback. This can lead to better patient sentiment, in fact, in times to come. So it's always a feedback loop. You goes on to that and improve yourselves. Then have a clinical documentation. Clinical documentation, as I already told you, that is one of the most redundant parts when it comes to the medical routine jobs. These solutions, NLP solutions, can streamline the documentation process. For example, as I told you, you can have a hell lot of documents while to sign, in fact, while getting the admissions to the hospital. So these can be streamlined. These can be done online, and lot of paperwork and lot of redundant tasks can be uh, removed. And obviously, for example, I go to a hospital, I have to sign a document in English. If I even if I don't understand English, for example. So these solutions can provide you documentation or the access in various languages, and they can, even in case of the doctors, in fact, for example, doctor is saying something over teleconsultation to you, and this NLP or text speech to text converters will write down the whatever the doctor is saying as a prescription, give it back to you. So whatever language the doctor speaks, whatever the language be it, you understand it or not, you will get it translated to the language of your choice and available in one click. This is what clinical documentation using an LP can provide you. Patient education, uh, we have already discussed that using chatbots or the virtual assistants. Uh, Patients or the peers can get access, uh, that the relevant information is available around the clock and is comprehensible. So it can help patient buy some time or improve their habits, and so on. Then obviously language translation we have already discussed. NLP capabilities facilitate communication between different healthcare providers and patients who may speak different languages. Predictive analysis and big data in patient care. So this is one of the another major um, pillars that help put AI in the telemedicine. That is like more big pillar that where AI can help. Data collection. Data collection means, as I already told you, large volumes of patient data are available here and there. So correlating them, collating them, even in fact data from wearable devices or your health apps, for example, Google Fit, how much time you work out, how much time you do this, how much time you do that. There are a whole lot of data available. Collating these data and uh, uh, make it comprehensible and present all that data as a summary to give a better insight about a patient condition or the health. That is one of the uh, use cases here. Then comes risk stratification. Predictive models can stratify patient based on the risk of developing certain conditions, such as chronic like diabetes and couple of heart diseases. This allows the medical providers to target interventions more effectively. So then personalized interventions we have already discussed a couple of times. By understanding individual risk factors, the doctors can personalize preventive measures to each patient. This may include lifestyle changes, screenings, medications, access to certain sort of medicines. Okay, these medicines cannot be taken by you because of this condition. Medicine has only this medicine has to be taken by you because of this condition. For example, you can personalize interventions. AI helps to develop personalized care plans, so that can lead to better results and showcase the benefit in like predictive analysis. Population health management, big data analytics can identify at risk populations, enabling public health initiatives by the government, in fact, to be more focused and effective. This can lead to improved health outcomes at a community level. As we already said, that some far-flung populations, maybe in the eastern or the far east, like remote areas, we can have their health analyzed using different things, and we can launch different community health schemes. The government can launch community health schemes based on those data. Obviously, the cost reduction by predictive analysis is a big help, or that can reduce the cost or reduce healthcare costs uh, by targeting the diseases in the early stage or even before the onset. Early interventions are often less expensive than treating the advanced rare conditions. Uh, Continuous monitoring, wearable technologies, and mobile health applications allow for continuous monitoring of patients with health metrics. This real-time data can be used to adjust preventive strategies as needed. With these technologies, medical providers they can ensure they stay ahead in patient care. Advanced diagnostics with Gen AI. So these are the few things that okay. Let's go one by one. First is, for example, image analysis. Uh, AI algorithms can analyze medical images, X-rays, this and that to detect abnormalities. Uh, this can include identifying tumors, um, fractures, etc., and different X-rays uh, to leading to timely interventions. Then automated reporting. AI can generate preliminary reports based on image analysis, streamlining the workflow for radiologists. This allows radiologists to focus on more complex cases and improve overall efficiency. Then I also then the next comes standardization of interpretations. Uh, like when we are using some X-ray reports, we are reading some X-ray or MRI reports using AI algorithms that can help standardize the interpretation, because every individual can have different style of reading. AI can help standardize the interpretation of imaging, reducing variability between different doctors. In fact, this leads to more consistent and what say we can say more reliable diagnosis, uh, leading to better results in diagnostic process. Then AI training and education. AI tools can be used to train radiologists by providing feedback on their interpretations. Okay, some radiologists provide a particular inference on a reading. AI can provide him the feedback. Okay, you may be wrong here. I read this, so that even a radiologist can improve upon his readings or the findings. Integration with clinical data. AI can facilitate imaging data with other clinical information. As I already told you, my father went to uh, a cardiac surgeon for certain condition. He suggested certain medications, but obviously he could not take those medicines because he had high potassium. So with all interpretation with all this clinical data is needed. So AI can integrate imaging data with all other clinical information, providing a comprehensive view of patient health. This holistic approach can improve diagnostic accuracy, and obviously better treatment planning, ultimately benefiting the patient and the healthcare industry as well. Then second is symptom recognition and pattern detection. This figure or picture that you can see is the symptom recognition and pattern detection flow chart. In fact, more or less, it happens in this way. So symptom recognition involves identifying, interpreting the signs and symptoms presented by patients. AI algorithms can analyze vast amount of patient data to detect patterns that may not be immediately obvious to healthcare professionals. AI can help healthcare people implement these algorithms, leading to more accurate diagnosis and better patients care. Then different machine learning models, which can be trained on the historical patient data to recognize symptoms associated with specific diseases. These models can ensure that they are tailored to the unique needs of various departments. For example, a cardiology department may have different sort of machine learning solution, machine learning model, or a neurology department can have a different machine learning model suited to their own tailor-made needs. Then we have already discussed the NLP, which can be utilized to analyze unstructured data from clinical notes, social media, patient different reports, and so on. Prediction or the early pattern detection can lead to timely interventions, improving patient outcomes and reducing costs. Trend identification. AI can also assist in identifying trends in symptom presentation, so which can be crucial in for managing outbreaks or understanding disease progression. For example, uh, even after COVID, even after COVID, uh, there have been many instances in across the globe in many locations that, for example, in Nigeria currently there is some virus that uh, is again communicable like COVID or even more, and is more life threatening than COVID that is happening around. So these patterns, there can be a predictive model or something that can detect these patterns, which can lead to timely interventions, or we can have better recovery plans uh, regarding to these different diseases. Real time risk prediction. involves using AI to ask a patient's risk for access a patient risk for developing a disease based on the current data, or maybe in analyzing the current data along with the genetic data or genome data that can predict the risk. Early disease detection, almost the same. The use of AI in real-time risk prediction can lead to personalized treatment plans uh, to suit the needs of various patients. In fact, predictive analysis can analyze factors as genetics, lifestyle, or in fact also this, for example, environmental influences to forecast high health risks. For example, as I told you already, for just given an example, the people in NCR might have a higher risk of getting lung related diseases uh, compared to people outside NCR. So these sort of predictive models can work on different environmental conditions as well as patient conditions, and combining genetic data or real-time data along with uh, in environmental influences or the individual lifestyle influences, we can combine all these data and provide a better insight to a patient's health impact. Now, as I've already discussed, what triage is, a triage is a process of uh, determining the priority of patients' treatments based on their condition. For example, some patients may require healthcare facilities more urgently than others. So AI can streamline this process by quickly analyzing data and symptoms to categorize the emergency levels or urgency levels. It reduces wait times and improve patient inflows in emergency departments. The integration of AI in emergency management can have enhanced communication and coordination among healthcare teams. Different machine learning algorithms can assist in making decisions about the patient care in emergency. By integrating different algorithms, we can have better decision making. Okay, I need to move this particular patient to this department right now. These tests need to be done on an urgent basis. So this particular healthcare professional can take care of this patient right now. So that can be done pretty easily, and different algorithms can help various hospitals or healthcare professionals take decisions regarding to triage. Then comes different like the triage, intelligent symptom checkers from triage, Gen AI based like predictive modeling, real time decision making, resource management, training simulations, communication enhancement. We have already discussed somewhere or the other. These all can analyze different types of data and provide you a better decision making scenario. Okay, we need to treat this particular patient urgently than someone else, and then come back to real time allocation based predictive analysis. Real time resource allocation involves some like predictive analysis to ensure that healthcare people are available in the hospital when they are needed. For example, I anticipate, obviously, some AI model can anticipate, obviously, at this particular instant in time or in this particular day of the week, we can have more patient inflows, then that will be heavier than usual. So hospitals or the healthcare institutions, they can plan their resources on those days in particular so that the resources are available when needed, especially during the peak times of emergencies. This strategic approach can lead to significant improvements in operational efficiency. Obviously, if we have certain accident in the middle of the night and go to a hospital, and only you can find only junior doctors and no specialists around, then that may lead to some critical emergency there. So there should be there are different models that can predict, okay, this particular time of the day or this particular instant in time or this particular day of the week, we can expect higher inflows or higher criticalities, so that different sort of healthcare people are available that particular instant in time. Predictive analysis relies on collected data, patient records, historical trends, real-time health metrics, or environmental things. Or, for example, I was just giving you an example of uh, uh, at some time in a particular day. For example, these days, for example, during winters, people traveling on the expressways or the highways are uh, more exposed to the fog conditions. So the chances of accidents are pretty high. So hospitals, for example, hospitals around the expressways or the highways, they need to be more proactive at night for the accidental cases, because that is when the chances of having accidents are more high there at that. But obviously, when the doctor is not around at the middle of the night, then it will be a problem. So these models can help optimize those costs. Then it can lead to better collaboration across different departments. Predictive analysis foster like different departments, ensuring that the areas of healthcare are aligned in their resource management efforts. I need, for example, patients in the healthcare people in one department, or the uh, pathology department, or maybe some other department. So those people should be available. So there should be a better coordination between different departments. This can be done. This can be achieved using different AI models. Remote patient monitoring and chronic disease management. So there are various use cases, like we have already discussed somewhere. Continuous patient monitoring with wearable devices. Uh, we have already discussed. Then becomes AI in chronic disease care, personalized treatment plans. We have already discussed. We can go ahead. Third is medication adherence and support systems. So this is something we can go through. Medication adherence refers to which patients take their medicines as prescribed. As we can see, not all of the patients are taking their all the medicines on time and stick to the schedule. It is crucial for effective treatment and improved healthcare outcomes. Support systems, including medication adherence support systems, play a vital role here. So, importance of medical adherence. It improves treatment effectiveness, reduces hospital visits, and enhances treatments. Factors influencing adherence, like side effects and efficacy, patients' understanding of their condition and treatment. So how can we go ahead and help here with AI? There can be automated, there can be mobile apps and AI related algorithms that can give you text messages or automatic reminders to patients to take their medicines on time. AI can send them personalized reminders, ensuring patients stay on track with their medication schedules. Then AI chatbots or different tools can provide them education and counseling, providing information about the importance of adherence and if what the problem will go if they miss, or what will be the side effects of not being on schedule. Then there can be uh, sh- multiple adherence monitoring tools, smart pill bottles, or electronic monitoring systems that can track uh, usage and alert the patients. Okay, this pill bottle has some this medicine need to be taken at this point in time. If this medicine is still in the compartment in that pill box, it will alert the patient. Okay, you have not taken this medicine. These doses are missed. So we can make these IoT uh, AI collaborative devices. We can give you uh, reminders, or they can prompt you or the patient, in fact, to take the medications on time. So, what are the advantages of Gen AI here using Gen AI in telemedicine? Personalization, we have already discussed. Accessibility, fine. Efficiency is fine. Symptom checkers, predictive analysis, improved diagnostic accuracy, and treatment recommendations. Fine. So, what are the challenges? This now the big issue here is the challenges in AI or Gen AI. In fact, first is data privacy. So, when all the patient data is at one single place, we need to ensure that it is protected first. Ensuring patient data that is protected, it is crucial in AI applications. Data security and compliance. Uh, these are implemented using robust methodologies to safeguard sensitive information. And even if the information is exposed somewhere, it should not be having the individual recognizable places like your ID or name should not be associated with your medical records. Suppose even if somebody accesses your medical records, he cannot recognize, okay, this belongs to you or some other patient. So this encryption or marking or this needs to be ensured when using the AI applications. Then obviously uh, all the AI or Gen AI algorithms, they work on different training data and different algorithms which can be biased, which can be made biased to for certain demographies or certain set of people, or even if the training data is biased to certain uh, for example white people or the black people maybe, for example. So the bias, we have to ensure the uh, there is no biasness when it comes to the AI modeling as well as the AI training data. So we need ethical AI, the use of AI in decision making that requires accountability. So we need ethical AI practices to ensure that human oversights remain integral clinical decision making. We should not go blindly with whatever the AI tool says. There should be somebody or a medical professional to oversee that. Okay, AI has suggested this. Okay, I comply to this. Okay, I agree to this, or I do not agree to this. So they should be overseen by some clinical decision making that is necessary. Then we have already discussed about the NLP and different chatbots, enhanced communication, patient education, appointment management, data collection, accessibility, language translation. And one thing that we might have missed is cultural sensitivity. Uh, Context aware, like you can say, the AI can adapt to healthcare messages, especially the language, to align with the cultural norms and values. One language that can be uh, one word or specific sentence that is acceptable, for example, in our language, may not be acceptable in some other language. So, to align with different cultural norms and values, improving patients' engagement, it can provide culturally relevant education, for example, based on a particular community's eating habits or a specific health concern in a particular community. So it can address those concerns. This tailor-made approach not only enhances patient trust, but also tries to provide a better insight into a community's health when it comes to community health programs. So going forward, AI in medication management, uh, intelligent prescription systems to minimize errors. So prescription systems utilize AI to reduce medication errors, which are like which can lead to adverse drug events, compromise patient safety. For example, there can be potential errors, misprescription or something, or maybe uh, doctor missed certain allergies that a patient had, or something that can lead to different outcomes. So AI reduces these errors Standardization, obviously, if you have this particular condition, for example, you can take this particular medicine. So going forward, this can help different patients using different help to standardize stuff so that it can help patients using different platforms. Data-driven insights, by analyzing different large data sets across the different parts of the globe, AI can identify pattern in medicational errors, allowing healthcare providers to implement targeting interventions. So AI can provide insights that can drive continuous improvement in medical management, especially when it comes here on the prescription medicines. Then there are certain use cases regarding the medical management. For example, compliance and refills. Refills means when you have to refill your medicines or the prescription medicines. You can have reminders for that purpose, personalized reminders. Monitoring compliance means uh, uh, some for example, so there are some systems or the trackers that can track the medication usage through smart pill bottles or wearables or providing real-time data, for example. So there are predictive analysis. They can analyze patient behavior and predict when a patient may be at risk of non-compliance. For example, you are going to a party or you are out of your place for a particular duration in time, and so our system can predict. Obviously, this patient is out of town or out of his home at this instant in time. He is more likely to miss his medication. So this type of predictive analysis uh, allows the healthcare providers to intervene proactively. They can give them a call or give them a reminder, okay, take your medicine now. So automatic refill management, we have already discussed. Uh, this smart pill bottles or automated reminders can help you get automated refill management when it comes to pharmacy things. When it comes to the, we are already running ahead of time. In fact, we have already passed the time, so I'll cut it short. So this is again related to the pharmacy and the retail inventory, inventory optimization, refill management and inventory management tools. They can help reduce the overstocks and understock options so that all the medicines are available when needed in optimum amounts. So you need not have a very big warehouse to store a lot of medicines which are rarely used. So different type of algorithms can be used to predict predict the historical data to forecast demand along the businesses, along the medical professions to make informed decisions. Sorry. These algorithms can predict usage and consumption and provide insights that derives economy. Obviously, you can save time, save money in not storing those medicines which are not used in large numbers, or they can be used only in small numbers. They can be stored only in small numbers. They can uh, improve the customer satisfaction through the timely product delivery or availability. That can be done. That this predictive model can be made using data from various sources such as like medicine sales, season trends, market conditions, demographies, environmental factors. These can be utilized to make a predictive inventory list, and these can be utilized for the same. So I'll cut it short. I'll come here that we come to the end of this particular session. I did not get into very technical stuff, but these were the various use cases that sorry, that can be incorporated or that can be implemented using various AI techniques that can help grow and optimize the resource optimization as well as the cost optimization in the telemedicine. So if you have any questions going further, you're most welcome.
Thank you so much, sir, for sharing your knowledge and expertise. This session is open to questions now. Please raise your hands. We will unmute you for the questions. Any participant want to ask?
In the meanwhile, Rakhi ma'am, I would like to thank Yuvraj sir, because in spite of not feeling well, he had given a wonderful presentation and it was very informative, sir. Thank you. Thanks a lot for the wonderful presentation, sir. And take care.
Thank you, ma'am. Thank you. And
Take
this
care, sir. Thank
this
you.
only seasonal. In fact, I've
Yeah.
been down with this cough and cold thing for the last couple of days. But yeah, it's fine.
Oh.
I was still be working. So these small issues cannot hinder your effectivity.
No, really. Thanks a lot, sir, for joining us today.
Thank you,
Thank you,
ma'am.
sir.
Thanks a lot,
Thank
and
you. Thank you.
that was very nice interacting with you all. Thank you. Have a good day ahead.
Same here, sir.
Thank you
Thank you,
so much,
sir.
sir.
Thank you.
Thank you.
Participants, we will have the next session today at 2 p.m. By Professor R.K. Agarwal, JNU, Delhi. You all can join back. Enjoy your lunch till then. Thank you.